Hey everyone, it's Mr. Retan here to explain to you how to solve trigonometric equations. So our learning goal this week is for you to understand how to solve some basic trig equations. And this is pretty straightforward. We're going to solve them a lot like we solve regular equations, except for at the end we have to think a little bit more deeply about trig equations and properties of the unit circle. So what we're going to do is walk through some examples. So we're going to start with a fairly basic equation. So if you take a look at example 1, it says find all values of x in the interval 0 to 2 pi that solve 2 tan of x plus 1 equals 4. So one of the things to keep in mind is we're looking for angle measures, and we're looking for angle measures in radians. So all of our answers will be some sort of either radian measure that's an exact value with pi, or it might also be a decimal. And remember, 2 pi is 6.28. So we're going to be utilizing our calculator as we work through this. So I want to remind you that you can access a TI calculator for free online. I put that in a previous post, but the other thing you can do is you can just use Desmos to solve most of these after you've done the algebra. So take a look at example 1. We're going to walk through that up on the board right now. All right, so the first equation is 2 tan of x plus 1 equals 4. So the first thing I'm going to do is I'm going to work on moving the 1 to the other side. There we go. So I'm going to subtract 1 from both sides. You solve this just like you would a normal equation, and you get 2 tan of x equals 3. Next step, I'm going to divide both sides by 2. Again, we're trying to get that marker's not any good. See if I can find another one. I'm going to try to get that tan of x alone. So if I do that, I get tan of x equals 3 over 2. And now at this point, we want to think about how do I undo tan? What's the opposite of tan? And so I want to do tan inverse. So here's where we're going to put to use what we did last week. So I'm going to say x is going to equal tan inverse of 3 over 2. And so if we type that in our calculators, so I'm going to demonstrate what that looks like on Desmos. So 1 second. We're going to go to Desmos right in on your screen. All right, so if I type, now I don't type tan inverse in here. I'm going to type arctan, because remember arctan is the same thing. And I'm going to type 3 over 2, and it gives me this crazy decimal. So we want to think about what tangent represents. So we get the decimal 0.983 approximately. So about 0.983 is my first answer. And I'm going to call this x1, and I'm going to explain to you why this is x1 right now. So 0.983 is an angle measure. If we sketch the unit circle over here, remember we have these key spots or landmarks on the unit circle. So we have 0, and then all the way around is 2 pi, which is 6.28. Then we also have, pi over 2 up here, and that's about 1.57. And down here we have pi, which is 3.14. And then we have 3 pi over 2, which is about equal to 4.72. So these are some key landmarks. So if I think about 0.983, 0.983 is going to be somewhere about right here. And I'm going to call this x1. So what we just figured out is what angle has a slope of 3/2 on the unit circle. So this angle, 0.983 radians, And if you really wanted to, you could change it to degrees and figure out what that is in degrees, if that's easier to think about. But that is one angle where we have a slope of 3/2. Now, the other, that's not the only place that this happens on the unit circle. So if you think about slope and where else on the unit circle would have that same slope, it's going to be the angle that's going to go directly across down there. So think about how much would I have to add from here to get down to here. And it's halfway around the circle in order to land on that same line. So it's going to be plus pi. So I'm going to take x1, and in order to get x2, I'm going to take 0.983, and I'm just going to simply add pi. So if we go back to Desmos, and let's do that right now, we're going to say we're just going to do plus, take this answer. Let's see, copy that. I'm sure there's a better way to do this. I'm having a blank. And we'll do this. Okay, arctan of 3/2, and then I want to do plus pi. And you can see that my next answer is 4.124, or 4.12, yeah, 124. So x2 is about 4.124. So since it said for us to find all the answers in the range from 0 to 2 pi, I've done just that now. I've gotten the first answer and the second answer. There are 2 spots on this unit circle where that slope is 1.5 or 3/2. So I'm done with this. Now, the other cool thing we can do is on Desmos, I could easily check to see if these numbers make sense by doing some graphing. So what I'm going to type in here, I'm going to type in one side, I'm going to type f of x equals, actually I don't even need the f of x. I'm just going to type in 2 tan of x plus 1. And that's the left side of that equation. I'm going to type 4. That's the right side. Actually, I guess I need y equals 4. It didn't recognize it without that. Y equals 4. So you can see the other thing I'm going to do, because it said I only want answers between 0 and 2 pi, I'm going to change my range in my x from 0 to 2 pi. And that will focus in on the only answers that we really need to worry about in this question. So right there, you can see, and right there are my 2 answers where those are equal, where they cross. And these are the 2 decimal numbers that we just got when we did our inverse functions. So that's the first example. So I'm going to go on now and we'll look at the second example. All right, the second example says find all values of x in the interval 0 to 2 pi that solve 9 sine squared of x minus 1 equals 3. This is, again, a similar type problem where we're trying to get sine alone. We're going to use some of the same steps we would normally with algebra. So we're going to isolate sine, and then we're going to use what we know about inverse trig functions and also some things about sine. So I'm going to increase the size here so we can look at the example together. All right, so the first thing I'm going to do is I'm going to add 1 to both sides. And if I add 1 to both sides, I'm left with 9 tan squared of x equals 4. Okay. The next step, I'm going to divide both sides by 9. Divide by 9, divide by 9. And I get tan squared of x equals 4/9. Next, I'm going to take the square root of both sides because I'm trying to undo tan squared. And that leaves me with tan of x equals, now since it was a square root and I undid it, I need a plus or minus in front here. That's an easy step to forget about. So it's going to be plus or minus 2/3. So that leaves us with 2 possibilities. So possibility number 1, and I'll put these over here. So possibility number 1 is that tan of x is equal to 2/3. And then possibility number 2 is that tan of x is negative 2/3. So we need to work through both of those possibilities, thinking about the unit circle and what this would look like. So remember, you know what? I just realized, let me go back to the problem a second. I may have made a mistake. 1 second. Oh, I did. Okay, this is important. I wrote it as tan. This is actually sine. So that's going to change things quite a bit. So I'm going to erase all of those. This should be sine. Sorry about that. So change all of those. The steps won't change. It's just wherever I wrote tan squared or tan, I'm going to change it to sine. So I'm going to change that all the way around. So actually, I found out that sine of x is 2/3, or sine of x is negative 2/3. All right. So now what we need to do is undo the sign. So the opposite of sine is inverse sine. So I know that x, I'm going to call this x1, is equal to sine inverse of 2/3. And sine inverse of 2/3 is, remember, sine represents the y coordinate on the unit circle. So the y coordinate has to be 2/3. So it's like, what angle gives you a y coordinate of 2/3? Again, we're going to use arc sine in Desmos. So we're going to go back to Desmos a second. And if I go to Desmos and I type in arc sine of 2/3, that will tell us that 0.729, or if I round it up, 0.730 is my first answer. So x1 is about 0.730. Now, since we're on here, I'm going to do the same thing. The other one was sine inverse, or sine of x is negative 2/3. So I'm going to call this x2, and so that would be sine inverse of negative 2/3. And so x2 is going to be about, so let's take a look at what that will be. So arc sine of negative 2/3. Okay, and that gave me an answer of negative 0.7297. So about negative 0.730. All right. So if we think about where the y coordinate is equal to these things, let's start with this side. So if I draw a little unit circle here. So remember, we know that this is 1.57. We know that angle-wise, this is 3.14, about 4.72, and about 6.28. Those are our radian measures. So I know that 0.73 is somewhere about right in here. And again, that is about where that y coordinate, height-wise, this y coordinate here would be 0.730. So this little dotted line I'm putting in there, that's about 0.730. The other thing I want to think about then is, where else am I going to have a y coordinate of 0.730? So one of the confusing things about these problems is, when you do arc sine or arc tan, it's only going to give you one answer because it's a function. However, when we solve these equations, if I'm saying I want all angles between 0 and 2 pi, there are multiple angles in a lot of these where you could get an answer. So in this case, there are 2 spots where I have a y coordinate of 0.730. We learned last week, hopefully, that sine inverse is restricted in this area on the right side because it's covering all the y coordinates. Okay, so in order to get the other spot, which is over here, because that's the this other place where the y coordinate is also 0.730, I need to do something with a 0.730. So what we're going to do is we're going to go all the way around pi, and then we are going, so if I go all the way to pi, let me grab another marker here. So if we go all the way to pi, and then I take away that angle, so my rule is going to be x, we'll call this x3, is going to be pi subtract 0.730. That will give me my other angle that goes with it right there. So back to Desmos, and if we work through that in Desmos, so pi minus 0.730, and that gives me 2.412. So x3 is about 2.41. By round, it's going to be 1, 2. All right, so that's my second answer that goes in that area. Okay, so that possibility 1, we have 0.730, and we have 2.421. And again, those are the two angles that have a y-coordinate of 2/3. Okay, so we found the first one by doing sine inverse. The second one we did pi minus the answer we got for that first one. Now, if you think back to the first example I did it with tangent. In that one, we had to add pi because tangent represents slope, not the y coordinate. So that changes the steps that we're going to use. Okay, so now in this last one, possibility number 2, so if we think about where that's located, so it's negative 0.730, somewhere down here. And, well, one thing about this answer is it's not in the range that we want. It's negative, and remember our answers are supposed to be between 0 and 2 pi. So we're going to have to deal with that in a minute. But the first thing I'm going to do is I'm going to apply that same rule. So I'm going to go x4 is equal to, or about equal to, pi take away the negative 0.730. And if I do take away this, it's really like I'm doing pi plus that answer. So that's going to give me this other angle. So if you wanted to just think about that as pi plus 0.730, that would give you x4. So x4 is going to be, let's see what we get. So pi plus 0.730, and I get 3.872. And now we're going to go back to that third answer. Actually, I have it labeled x2 up here. So this answer, the problem with this one is it's not in our range. So I need to go, so one weird thing is sine inverse and tan inverse, you can get answers in the fourth quadrant that are between negative pi over 2 and 0, this area over here. But we don't want them negative when we solve these because it said between 0 and 2 pi. So I'm going to have to add 2 pi. I'm going to have to find the coterminal angle to this, so plus 2 pi. So if I do negative 0.730 plus 2 pi, let's see what we get. So negative 0.730 plus 2 pi. So I get 5.553. 5.553, and that would be my fourth answer or third answer, either way. So I don't know. As long as you have 4 answers, the subscripts really don't matter. I numbered it 1 and 2 here and 3 and 4. That doesn't matter. You just need, in this sort of a problem, you have 4 solutions. You need to have all 4. So let's check that one more time on Desmos. Let me demonstrate again how we do that. So in Desmos, I'm going to go back to just type in on one side, we had 9 sine of x. So to do the squared, I'm going to put this in parentheses in Desmos. You can't, I don't believe you can put the power in Desmos like we have in our equation, minus 1. And then on the other side, we had I'm going to say y equals 3. And again, I'm going to change my window, and I'm going to make it just go from 0 to 2 pi, and we can zero in on what solutions we got. So 0.73, 2.412, 3.871, and the final one 5.553. And those are the exact solutions. Well, they're all rounded, but those are the solutions that we found when we did it. So that's your second example. All right, this next example, it says on your notes example 4. I just realized that's because I deleted an example that involved trig identities. But anyway, this fourth example is one where it's called solving indirectly. So what we're going to do is we're going to solve this quadratic by kind of just renaming things. First, because I have a squared term and a non-squared term and a number, I'm going to try to get everything on one side. So I'm going to have 2 sine squared of x plus sine of x minus 1 equals 0. So I moved everything to one side. And now this next step is optional, but it's a good thing to know. It's called substitution. It's just we're renaming sine of x as a variable y. So I'm just going to say y is equal to sine of x, and I'll just say let y equals sine of x. So I'm just going to rewrite this 2y squared plus y minus 1 equals 0. And the reason I did that is just to make it easier to look at. That's all. And if you'd rather just keep it sine of x and sine squared of x, that's fine. So once we've rewritten it, we're going to factor. So remember, we learned earlier this year, we have factoring, we have completing the square, we have quadratic formula, we have all these different tools to solve quadratics. Any of those tools are fair game here. And so in this one, I know right now that I can factor it. So I'm going to start thinking about what, when I multiply it out, would give me 2y squared plus y minus 1. So for 2y squared, I know I have to have 2y and y. For the 1 at the end, I need a 1 and a 1. The only thing I really need to figure out is the signs. Since that is negative, I know I need a negative and I need a positive. And so I just have to think, since this is plus, I want more positive than negative. So that means when I multiply the 2y by the 1, I want that to be positive, and I want this one to be negative. So if I were to distribute this out and figure out what I have, I should have exactly what I had up here. So you can make the box and check that. All right. So next, I'm going to say, well, then 2y minus 1 has to equal 0, or the other possibility, y plus 1 has to equal 0. And that means that 2y would have to equal 1, or y is equal to a half. That's your first possibility. And then in the second one, y is equal to negative 1. Next, I know that y back up here is the same as sine of x. So all this time when I've been writing y, I could have been writing sine of x. I'm just writing y to make it easier to look at. So I'm going to change this to sine of x equals a half, and sine of x equals negative 1. So I have both those possibilities. And now one of the things about this problem is these are nice exact values on the unit circle. So the first one's saying, okay, find the angles where sine of x is a half. So I could use the calculator, I could do Desmos and get those crazy decimals, but I know based on the amazing unit circle that sine of x is a half right here, and it's also going to be a half over here. And so let's go to the unit circle because it's cool and it's helpful. So I'm going to search unit circle, and we're going to zoom in on a unit circle a second. Maybe. Here it is. All right, so I'm going to move me, maybe, if I can figure out how to do that. There we go. Now I'm over here. Okay, so if I want to know where is the y coordinate half, I can see it's at pi over 6 right here. And I can also see that it's at 5 pi over 6. If I wanted to get crazy in Desmos and type that in like before, I'd get some decimal equivalent values to that. I know if I was in class, some of you would ask, is that okay to do it that way? And I would say, yes, it's okay, but I also want you to understand this method, that you could look at the unit circle and some of these exact values. Thing to keep in mind is not all the problems we're going to do are exact values. So sometimes this will work, sometimes it won't. For example, if I had like sine of x is a third, there's no y on here exactly that's a third. that we can see easily. So anyway, my first two solutions are going to be, so x1 is pi over 6, and x2 is going to be 5 pi over 6. And I could use those rules like before. I realize I got to make this bigger for you. There you go. Now you can see it a little better. So, oops. All right, so pi over 6 and 5 pi over 6 are my first two solutions. This last one is interesting. This is saying, where is the sine equal to -1? Or in other words, where is the y coordinate equal to -1? So we know that that's down here at the bottom. And if you think about what angle that is, it's either negative pi over 2, which is what arc sine would tell you, negative 1.57. But we want the one that's between 0 and 2 pi. So what we're going to say is this is 3 pi over 2. So x3 in this one is 3 pi over 2. Now, if I try to do that rule in this one where I do pi minus the first answer gives me the second answer, it's going to give me the same answer. There's only one place where you get -1. It's unique there. So one of the visuals I like to do when we do these problems, so we did tangent first. So I'm going to try to do this on screen. So tan is slope, so it's like an airplane. So when you have that image on the unit circle, it's like this, airplane, okay? Sine is the y coordinate. So sine is either up here, like this, or it's down here, like this, okay? Cosine is the x coordinate. So cosine is on the side, like this, or like, this is hard to do on screen, but oops, something like that, there we go. So that's your math dance for the day. Let's go back to our notes and talk a little bit more about a few other things. Oops. So one of the things I want to quick show you is we could again check our answer on Desmos. See if I can move my, there we go. So if I wanted to go to Desmos here and type in this one, if I wanted to type in the left side, which is, we started out with 2 sine of x squared, and then we had plus sine of x, and we want to know when is that equal to 1, and we never want to lose sight of what we're really finding here. We're finding angle measures, and so these angles have to be between 0 and 2 pi. And again, if we click on those, you can see right here, hey, in Desmos, because Desmos is so cool, they give you these exact values. And those are the answers that we came up with. So it's also kind of cool to see where this one here only crossed one time because you were at the peak. These, you could see it had to cross twice. So that's kind of cool. Interesting graph there too. So always a good idea to check in Desmos to confirm your answer if you have that ability. The other thing that it says in your notes, if we go back to our notes a second, is that if we expand to say that our answers could be any angle, not restricted to 0 to 2 pi. So let's go back to right here. You could generalize in this to a set of all answers for the set of all answers. So the way we do that is we think about coterminal angles. So if I wanted to, let's go back to Desmos again. And so the graph that I had, so it was 2 sine of x squared, and then plus sine of x, and then we want to know when is that equal to 1. So if I were to not adjust my window just to the answers between 0 and 2 pi, I could just keep going. This is going to have an infinite number of solutions. You just could keep going and going and going. So I could keep sliding this over and over, and you can see it's going to repeat that pattern again and again. So there are really infinite numbers of solutions. So the way we write that is we generalize whatever our solutions are, we just say plus 2 pi n. And in the Desmos activity you're going to do later in this assignment, you're going to see that. So I could say that x1 is pi over 6 plus 2 pi n, because remember 2 pi is one time around the circle, so I can just keep going around the circle again and again, and where n is any integer. So n could be any integer, and we could do that with each of those solutions. Our second solution we could say is 5 pi over 6 plus 2 pi n, and then the third one is just going to be 3 pi over 2 plus 2 pi n. All you do is you add 2 pi n to the end of whatever solution that you just got. All right? So a few more. So we want to remember when we solve trig equations that when we do those inverse sine or arcsine, arctan, or arccosine, we have restrictions where it's only going to give us one answer. But oftentimes there are more than one answer. So just a reminder in your notes, sine inverse is restricted. It's covering all the y coordinates, and that to do that, it goes from negative pi over 2 to pi over 2. That's the restriction on sine inverse. Realize I got to zoom, or I got to make this bigger. There we go. Negative pi over 2 to pi over 2. Cosine is restricted to 0 to pi in the range, cosine inverse, and that's because that covers all the x's. And then tan is slope, and that's restricted from negative pi over 2 to pi over 2. And the reason it's not including negative pi over 2 and pi over 2 is because we can't find the slope at those endpoints at the top and the bottom. So that's why we restrict it, and we don't include the endpoints. Okay, so when we find the other solutions in trig equations for sine, so any equation that involves sine, the rule will always be you take your first solution, actually you do, so we'll say x2 equals pi subtract x1. So we take our first solution and subtract it from pi. And a good image is this one. This is this thing here, all the y coordinates. Okay. To get the other solutions for cosine, this is the one I hadn't done an example of, but very similar to this, except we're going to do 2 pi. So if we think about the whole unit circle, and we want the same x coordinates, so we could have circle kind of looks like that, and if this is x1 and this is x2, we'd say x2 equals 2 pi subtract x1, and that gives you all the solutions for cosine. So if I do cosine inverse and I get a solution, I have to do 2 pi minus that solution to get x2. Okay, and then the third one, when I'm solving tan equations with trig, remember tan is slope, so here's my first solution, and here's my second solution. This is the airplane idea, and so if I have x1, x2 is going to be x1 plus pi, so x1 plus pi will give me x2, and that will tell me what other angle has the same slope. So so remember up here, so tan, I'm only going to get answers over on this side, so that's why I have to add pi to get these answers. In cosine, I'm only going to get answers up here when I do the inverse function, so I have to do this rule down here to get the answers in the bottom. Same with sine, I'm only going to get the answers over here when I do arcsine, so I have to use these rules to get the other answer. So I gave you a lot of information, and I really wish we could be in class together so I could explain more to you individually and take questions, but please feel free to email me. And also, if you can make it to the Google Meet on Tuesdays, that's great. I've seen a lot of you there, but love to see more of you. Also, if that time doesn't work, I understand you've got lots of stuff going on, and this is very unusual during this time. But if you'd like to, I'd be happy to meet with you another time. Just send me an email and request for another time. So I hope everyone's doing well. I miss everyone. Take care.